So today we're looking at the Conic's review key video. So we're going to do all these problems from the review sheet to help you guys get ready for the test on Friday. All right, so we start off with parabolas. Okay, because the x is being squared right here, that means the graph's going to either go up or down. Since this is a -4, it's going to go down. The vertex is h comma k. H is always next to the x, which is going to be 1. The k is always next to the y, which is going to be -3. Again, notice that the numbers come out as the opposites of what they were in the parentheses. The focal distance. I'm going to take -4, which is right here, and divide it by -4, which gives me a focal distance of 1. Now before I do the rest of this, I'm just going to start graphing this stuff so it's easy, because I think it's easier to find the focus and the directrix pieces after I graph the first couple parts. So my vertex is 1, -3, which is going to be right there. And my focal distance is 1. Since my graph's opening down, I'm going to go down 1, put my focal point, which is at 1, -4. And on the opposite side is my directrix, also up 1. And that's going to be y is equal to -2. So I'm almost done with my graph. I just need to find the last 2 points. To find those, I multiply the number 2 by my focal distance, which gives me 2. I put those numbers on either side of the focus point, and I graph. And I'm done. Which moves me to number 2. So now because y is being squared and the 8 is positive, my graph's going to be going to the right. My vertex is h comma k, which is 5, -4. So 5, -4 is going to be down here. My focal distance is 8 divided by 4, which is 2. Since my graph is opening to the right, I'm going to go to the right by 2 and put my focal point, which is going to be at 7, -4. My directrix is 2 behind the vertex, which is going to be right here, at x equals 3. Almost done. I got to find those 2 points. I'm going to multiply the number 2 by my focal distance of 2, which gives me 4. So I'm going to go up 4 from the focal point and down 4 from the focal point, and then finish my graph off. There's the second graph. Next, we're given a graph. We want to write the equation. So it's opening down, which means the x is going to be in front, and the p-value is going to be negative. My vertex is at this point right here, which is at 1, -2. Okay, my focal distance is going to be 3, the distance between the vertex and the focal point. So I can start making my equation. Since it's opening down, the x is out in front. -1 quantity squared is equal to, my p-value is 3. I'm going to multiply that by -4, so it's going to be -12 because it's going down. And then y plus 2. And there's my equation. On to number 4. So it's going to be opening right, which means my graph is going to be starting with y that's being squared. My vertex is right here, which is 0, -2. And my focal distance is 2. So if y is going to be out in front, y plus 2 squared equals, the focal distance is going to the right, so it's positive. I'm multiplying 4 by 2, which gives me 8. And then x. I could put plus 0. I don't need to. I could just put x or 8x without the parentheses. Either way, it's fine. But that's the answer to the equation. All right, number 5. Now we're given some information and asked to write the equation out. The best suggestion would be to sketch a graph of what's going on. And using that sketch, we can better understand what's going on with our equation. So our vertex is -2, -7, so it's going to be way down here. The focus point is -2, -2, which is right there. So because the focus point has to be inside the parabola, my graph's going to look like this. Which means the graph is going to be an x squared and it's going to be a positive. So I'm going to have x plus 2, quantity squared, is equal to. Now my focal distance from -7 to -2, this distance here is 5. So I'm going to multiply 4 times 5 to get me 20, and then y plus 7. All right, moving on. Same idea, we want to draw a sketch. Your focus point is -2, 4, which is going to be up here. Your directrix is y equals 0, which is going to be on, I'm going to change colors here, on the x-axis. All right. So what it tells me is someplace in between those two is going to be my vertex. All right. It has to be directly between the directrix, the red dotted line, and the focus point that I drew first. So that means it has to be at -2, 2. My graph's going to look like this. So that means the graph is going up, so x squared is first. It's going to be x plus 2, y squared, is equal to the focal distance between the vertex and the focus point is 2. So I'm going to multiply 4 times 2 gives me 8. And then y minus 2. That's my equation. All right. Moving on to to ellipses. Ellipses. Now the reason I know it's an ellipse, and it's going to be important for the test, is that it has a plus sign. If it has a plus sign between my fractions, it's an ellipse. If there's a minus sign, it's a hyperbola. So my center is h, k, just like my vertex is my parabola. It's going to be 3, -2. Again, the signs will change as they come out. In an ellipse, the a value is always the biggest number in my denominator of my fractions. So a is going to be 5, b is going to be 4. Okay, and my focal points, I'm going to use my equation. C squared is equal to a squared minus b squared. So if a squared is 25 and b squared is 16, 25 minus 16 is 9. So c squared will equal 9. But I want to know c, so I square root both sides and you get 3. So I can draw my ellipse. So my center is 3, -2. All right. My major axis length is 5, and since it's underneath the x term, I'm going to go left and right by 5. 1, 2, 3, 4, 5. 3, 4, 5. And then since the 16 is underneath the y, I'm going to go up and down 4 from the center. 4 is right there. Right there. Try and draw my ellipse as best I can. And then lastly, I have to draw the focal points in from the center. Now the focal point should always go along the major axis length, which is defined by the longest side, how the graph is orientated. So that's, since it's along the x-axis, I'm going to go 1, 2, 3. 1, 2, 3. So there's my focal points for this particular graph. And that's done. All right, in this case, the center is 1, 0. Since there's no k value that's listed, it's a 0. Your a value is the biggest number in the denominator, in this case 81, so the square root of 81 is 9. That means the b value is 8. My focal points are going to be c squared is going to equal 81 minus 64. 81 minus 64 is, square root is 17. Take the square root of 17. I'm just going to find out what it is. My calculator here, which gives me 4.1. Okay, so now using that information, I can start graphing my ellipse. So 1, 0 is going to be right here. All right, since the 81 is underneath the y value, I'm going to go up and down by 9. The b is 8, so I'm going to go left and right by 8. That's too many. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Okay. Get rid of those dots. All right, now I can draw my ellipse the best I can. It's okay. And then my focal points, since my graph is going up and down, it's orientated vertically because the y value is the longer length. I'm going to go up by 4 and a little bit, and down by 4 and a little bit for my focal points. And that's my graph for my ellipse. Now your ellipse doesn't have to look perfect. Do the best you can. Actually, this is kind of bothering me. It's a little bit better. It's not perfect. It's okay. All right, on to question number 9. So now we're given an equation of ellipse. Or sorry, we're given the graph of an ellipse. We've got to find the equation. Okay, so you need to find the center point first. So the center point's going to be actually right here. So my center point is 0, 2. My a value, since the graph is horizontally orientated and the focal points are along the x-axis, we're going to go out 1, 2, 3, 4, 5 on each side. So that's a is 5. B is 2. Okay, so I know we're going to have x squared plus y minus 2 squared equals 1. Don't forget the squareds in the equals 1 part. That's part of the equation. All right. Underneath the x is the a value, so I'm going to put 5 squared is 25. Underneath the y is the b value, so 2 squared is 4. There's your equation. All right. Again, we're going to try and find the center, so that's going to be, looks like here, which is at -1, 0. My a value goes up and down. I'm going to go up 1, 2, 3, 4, 5, 6. My b value is going to be 2. So I write my equation. So I'm going to have x plus 1 quantity squared plus, because I know it's an ellipse, y squared. I'm going to get rid of the parentheses. Hold on. Equals 1. Don't forget the equals 1 part. All right, this time, since the longest part of my major axis length is going up and down along the y-axis, I'm going to put 36 underneath the y and put 4 underneath the x. That's that equation. All right, next I have some information. Again, just like with the parabolas, I would recommend sketching this graph so you can see it and then manipulate it to give you the answer to find the equation. So, the focal points are at -6 and +2, and 0, +2. So those are right there. So that means my graph must be horizontally orientated, which means it's going to be longer than it is taller. Okay, so my center of my ellipse has to be someplace between those two spots, which means it's going to be right there. That's your center. Which between -6 and 0 gives me a center of -3, 2. Okay, so my major axis length is 10. So if I go out 10 from either side, I'm going to have my graph. Okay, so if it says the major axis length, that means the a value is 10. We need to find the b value. To find the b value, we're going to use our formula for the focal points. We have C, we might not be given it to directly, but we know what C is, we can find it. We have A, we're given that directly, we need to find the B value. So the C value is the distance between the center and our focal points, which is going to be a distance of 3. Okay, so our C value is 3 squared equals 10 squared minus B squared. So now we need to find whatever B squared is. We don't need to actually find B because we're looking for B squared to put it in the equation. All right, so we have 9 equals 100 minus B squared. So we're going to get -91 equals -B squared. And then we're going to change both those signs. We divide it by 1. So B squared will be 91. So I can now make my equation. I have x plus 3, quantity squared, plus y minus 2, quantity squared, equals 1. Don't forget the squareds and the equals 1. Then, since the graph is horizontally orientated, which means, again, it's longer than it is taller, the a value goes underneath the x, so I'm going to put 100 right there. My b squared value I just found from my focal point equation gives me 91. And that is my equation. Right. Same idea. We're given some points, though, this time. So I'm going to graph my points. I got -8, -7, -8, +3, -6, -2, and -10, -2. So my graph's going to look like this. Okay, one trick way to find out what your center is find out where the numbers double up. You got -8s and you have -2s. That means our center of our ellipse is going to be -8, -2. Right? We need to find out what the distances between the points are to find out what our a and b value are. Okay, so from the top, let's go do from the bottom to the top, we went from -7 to +3. So that's a distance of 10 total. So that means half of that is going to be your a value, which is 5. All right, on the other side, from -6 to -10 is a distance of 4. Half of that is 2, which is your b value. So now we have everything we need. We do know that the graph is orientated vertically, so that means the a value is going to go under the y term of our equation. So we have x plus 8, quantity squared, plus y plus 2, quantity squared equals 1. The a should go underneath the y term, so we're going to have 25, and the b goes underneath the x, so we have 4. And there's your equation for your ellipse. Moving on. Now, this is a hyperbola, and the reason we know this is because there's a minus sign between the two fractions. Okay, again, that's the difference. That's how you tell the difference between a hyperbola and an ellipse. Ellipse has a plus, hyperbola has a minus. All right, otherwise, they work very much the same. There are a couple rule differences, but they're constructed pretty the same. All right, so the center is still h, k, so we have 1, 3. All right, and a hyperbola, the a value always comes first, and it's the numerators that switch. Okay, so the a value in this case is going to be 6. The b value is going to be 2, because the a value always comes first. The focal length formula for a hyperbola is going to be c squared equals a squared plus b squared. Okay, so we have c squared is equal to 36 plus 4. So c will equal the square root of 40, and the square root of 40 is, let's figure that out, 6.3. Okay, with this information, we can start graphing our hyperbola. So our center is 1, 3. Our a term is 6, and since it's underneath the x-axis, it's going to go left and right by 6. Our b value is 2, so I'm going to go up and down by 2. I'm going to draw a little box, a dashed box, that connects all these points of a and b. There we go. Next, after my box is drawn, I'm going to draw some diagonal lines that go through the corners of the box and then also through the center. This can be a little bit difficult with these narrow boxes. Do the best you can. It's not going to be perfect, but it should be as close as possible. Okay, those are going to give our lines of our hyperbola some definition. Okay, now since the x term is the one that's positive and being squared, because it's out front, okay, then what we're going to do is we're going to draw our graph along the x-axis. So from these points on the box, on either side, we're going to draw our graph. It's going to be bounded by these diagonal lines that we drew through the corners of the box. Okay, so that's the first part. The next part and the last part is going to draw the focal points. So from 6.3 out from the center, 1, 2, 3, 4, 5, 6.3. Do the best you can. I know it's not going to be perfect because we're really close to the points that you're drawing for the graphs. All right, but do the best you can. And that's what the graph should look like. All right, please make sure your lines for your graph do not cross through the diagonal lines that you made that are dashed. That would be incorrect. All right, another example. This time you can see that your h and k now have been switched. Your a value, though, is still the first one. So our center, h comma k, is 2 comma negative 4. Your center is going to be, your a value is 5. Your b value is 7. So it doesn't make a difference in a hyperbola that the b value is bigger than the a value. That's fine. In this case for hyperbolas, a's are first, b's are second. All right, your focal length is going to be c squared is equal to 25 plus 49. So 25 plus 49 gives you a grand total of 74. And the square root of 74 is 8.6. Okay, so now we can start graphing our hyperbola. We have 2 comma negative 4, which puts it right there. Our a value, in this case, is going up and down on the y-axis. So we're going to go up and down by 5. Okay, I'm going to go left and right by 7. And start making my box. All right, once I've done my box, I can make my diagonal lines that go through the corners and the center of my box. Now, because the a value is underneath the y term, my graph's going to go up and down. So at the point on my box, I'm going to go up, using the diagonal lines as my guide. And lastly, I'm going to put in the focal lengths from the center. So I'm going to go up by 8.6. It's 5, 6, 7, 8.6. So somewhere around there. That one's going to go off the graph. That's fine. 5, 6, 7, 8.6. Somewhere around there. And there you go. There's your graph. All right. Next, we're going to look at the equations if we're given the graph. Okay, so our center of our graph, you can see it right here, is going to be 3 comma 3. Since the graph goes left and right, that's what the a value is going to be. So it's going to be 3. The b value is going to be the one that goes up and down, which is going to be 4. Again, it doesn't make a difference which one's bigger, it's which one's first. And since the graph is going along the x-axis, the a value has to be left and right. I don't really care about the focal length for this because it doesn't make a difference for the equation, so I can leave that blank. So my graph will be, since it's opening along the x-axis, is going to be x minus 3, quantity squared, minus y minus 3, quantity squared equals 1. And then the a value gives me a 9, the b value gives me a 16. Now, important piece here for doing these types of problems, a lot of students will flip these around and put the y minus 3 first. Okay, that changes what the graph will look like because that means the graph then goes up and down and not left and right. So the order does make a big difference for a hyperbola because the fraction that's positive versus the one that has a negative in front of it is the direction the graph goes. Since the graph goes left and right, the x term has to be the one that's positive. So you've got to make sure the order does make a difference in a hyperbola. Technically, because ellipses have pluses, it doesn't. But if you're consistent, it helps. All right, our center for this particular hyperbola is right here at is at -1, 0. Because the graph goes up and down, that means the A value has got to also go up and down, so it's 1, 2, 3. The B value goes left and right, which means it's 2. Again, I don't need the focal length because it's not part of my equation. All right. So my center, since it goes up and down, has to be y squared minus x plus 1, quantity squared, equals 1. The A value is 3, so that makes that 9, and the B value is 2, which makes that 4. Again, because the graph's going up and down, the y term has to be first. Okay, if you don't put it first, then you've done it wrong. Moving on to some circles. All right, circles are pretty simple in terms of the ones that were already in the standard form. Our center is going to be the same as the center for an ellipse, a hyperbola, or the vertex of a parabola, h, k. So my center is -3, 1. My radius is that last number here, 36, the square root of 36, which gives you 6. So -3, 1 is my center. I go up 6, go to the left 6, go to the right 6, and go down 6. I draw the best circle I can. That's a pretty good one, and I'm done. Number 18 is a general form. So we have to find, or we have to make the general form into the standard form. So what we're going to do is we're going to take these two numbers, the 8 and the -10. We're going to divide both of them by 2 and square them. So I will get, I'm going to do it down here, I'm going to get x squared. If I divided 8 by 2, I'm going to get 4, and if I square it, I'm going to get 16. If I took the -10 and divide it by 2, I get -5, and if I square it, I get +25. I'm going to take this 5 and bring it to the other side, so it's going to become -5 because I subtracted it. Then I added 16 and 25 to the right-hand side because of the squared versions of it when I divided the 8 and the 10 by 2. All right, I can then convert these problems by factoring to be x plus 4, quantity squared, plus y minus 5, quantity squared, equals 25 plus 16 minus 5 gives you 36. Okay, so now I know my center of my circle is -4, 5, and the radius of my circle is 6. So I go -4, 5. I'm going to be 1 off. That's okay. I'll be here. I'll be here. 4, 5, 6. Oops. It was a 1 off on that one. Right there. And then right there. So I'm going to make my circle after that. All right. Here, write an equation for the circle graph. This is a little bit harder sometimes from the ellipses when you're doing this because it's a little bit more tricky to find the center. Trying to find the long points and then find the middle where those meet. It's going to be right about there. So I'm going to hit -2, -1. That's the center of my circle. From there, I count to any edge. 1, 2, 3, 4, 5, 6, 7. So my radius should be 7. Now, if you want to check to make sure your center is right, it should be 7 away from every edge. So if I go to the left, it's 7 away. If I go to the right, it's 7 away. If I go down, it's 7 away from the center. So now, I write my equation. So I have x plus 2 squared plus y plus 1, quantity squared, equals 7 squared is 49. And that's my equation for my circle. Okay. This is a how to write a circle using various information, kind of like we did with the ellipses. All right. We can sketch a graph of this. So we have 5, 6, 5, -2, 9, 2, and 1, comma 2. So our circle should look like this. Now, one way, just like we did with ellipses, if you find the doubled numbers for the points, you have 5 and 5. You have 2 and 2, which means your center for your circle should be 5, comma 2. We just need to find out the distance between the points to find out the radius. So if we take the total distance and divide it by 2 from one point to the other, that will give us our radius. So if we look at 6 and negative 2, that is 8 away from each other. Half of that would be 4, so your radius would be 4. So your standard form for your equation for your circle would be x minus 5 quantity squared plus y minus 2 quantity squared equals 4 squared, which is 16. And there's your equation. All right. We're going to try some of these word problems. Again, just a quick note for these problems. These word problems on the test are worth 3 separate standards. The first standard is, can you take the word problem that we have and then draw a picture of it? The second standard is, can you take the picture and make an equation out of it? And the third standard is, can you solve that equation for whatever it's asking us? Okay. So number 1, we have a parabolic arch. We're going to draw a picture of a parabolic arch. Here we go. Oops. All right, the span is 120 feet, which means half of it is 60. The maximum height is 25 feet. Okay, so we know some things about this. Actually, this is not the best. I'm going to redo this picture because it's really ugly. Let's try this again. There we go. So 60, 25. So we know 2 things about it. Then we know 2 points. We know this point is 60, comma 0. Excuse me. We know this point is 0, comma 25. So the point above, the 0, comma 25 is your h and k. That is your vertex of your parabola. And the 60, comma 0 is just an x and a y part. Okay? So it asks us to find the equation of the parabola and determine the height of the parabola 15 feet from the center. This is actually 2 separate questions. The first one you need to do is find the equation of the parabola. All right, in order to do that, we're going to write our equation and fill in the missing pieces with this information we have in our picture. Okay? So it's going up and down, which means x is out in front. The vertex is 0, comma 25, which means we're going to have x squared equals negative 4p times y minus 25. Okay, now what we're going to do is we're going to put the 60, comma 0 into our equation for x and y, and then solve for p. In order to find our equation, we need to know what that p value is, and right now we don't. So I'm going to put 60 squared equals negative 4p 0 minus 25. So now you're going to use a calculator to find out what that p value is. All right, negative 4p times negative 25 will give you negative 100, or sorry, positive 100, my apologies. 100p equals 60 squared is equal to 3,600. We're going to divide both sides by 100 to get p by itself, and p will equal 36. So we're going to put that back into our equation there. I'm going to have x squared equals negative 4 times 36 gives me negative 144, y minus 25. This is the equation of our parabola. So that's the first step of our question. Now what we're going to do is do the second part. It wants to know, determine the height of the parabola 15 feet from the center. So if the center is here, if I go 15 feet across and I go up, I want to know, what is this point? Okay, this point, I'm going to actually make it a different color. This point is the one we're looking for. It's 15 feet across, so it's going to be 15, comma, do we know the height? No, that's what we're looking for. So if we don't know the height, and we're looking for the height of the parabola, it's going to be the y value. So what we can do then is put the 15 in for x of our equation, and we can solve for the y that we don't know. So if I did 15 squared equals negative 144 times y minus 25, I can then solve for the y value, and then we'll be way on our way. So we have 15 squared is 225. I have negative 144 times y, and then negative 144 times negative 25 gives me positive 3,600. Okay, next I subtract 3,600 from both sides. Gives me negative 3,375. That is a 7. There you go. Equals negative 144y. Now I divide both sides by negative 144. And y equals 23.44. And then I'm done. So the first thing I do again was take the information from our word problem and make a picture. Then using that picture, make an equation to find the p-value, and then finalize our equation for the parabola. And using that equation from the parabola and more information from the problem, find the y value that is 15 feet from the center of our parabola. So this is question part 2, or part 2 of question 1. All right, let's try the next one. Change back to blue. All right, the arch of a bridge is in the shape of a semi-ellipse, so it's going to look like this. Okay, the bridge spans 30 feet across, which means if you go half of it, it's 15, and has a maximum height of 12 feet. So this is 12 feet. So I know 2 points, just like I did with my parabola up top. I know 0, 12, and I know 15, 0. Okay. I also know my center is right there at 0, 0. So I can start making my equation for an ellipse. Okay. So I can solve the rest of the question, because I want to know how high is the bridge 6 feet from either end. Again, we talked about this when we did these types of problems in class, and how it was tricky for students. So we're going to delve into why it is tricky, and hopefully you can not make the mistake. All right, so our equation is going to be x squared plus y squared. That's because our center is 0, 0, so I don't have any h and k values. I'm going to put equals 1. All right, it's longer horizontally than it is vertically, so it means my a value is going to go underneath my x term. So my distance, my semi-major axis length my a value is 15, so I'm going to put 225 underneath the x, and I put 144 underneath the y because the height is 12. So that's my equation for my ellipse. Now I need to find out how high is the bridge 6 feet from either end. So 6 feet from the end, if I go this way is 6 feet, I want to know where the graph, or where the ellipse is, how high that ellipse is right there. The problem is the 6 feet is kind of like a tricky piece. I don't care about the 6. I care how far away it is from the center. I care about this distance. So if the whole thing is 15 and it's 6 feet from the edge, that means from the center, it's only 9. So this point is really 9, y. That's what I need to know. Okay, so when you see 6 feet from either end, we don't care about the end necessarily. That's an important piece of information, but we want to know how far away it is from the center. If it's 6 feet from the end, that means it's 9 feet from the center, for a total of 15 feet. Okay, so we're going to use the 9 value in for the x term of our equation. So I'm going to have 9 squared over 225 plus, we're looking for the y, 44 equals 1. Now to solve for the y squared, we have to subtract 9 squared over 225 from our 1 value. All right, so we're going to use our calculators for that. So we have 1 minus 9 squared divided by 225 gives me 0.64. So I have, I'm going to go up here. I have y squared over 144 equals 0.64. All right, in an effort to continue solving for my y value, I'm going to multiply by 144 to get it off the bottom of our denominator. So 0.64 times 144 gives me 92.16. And lastly, we got to solve for y, so we're going to square root both sides. Gives me 9.6. So 9 feet from the center, or 6 feet from the end, the height of the ellipse is 9.6. Okay, let's look at the next one. A satellite dish is parabolic with a diameter of 50 inches at its widest point. So we got another parabola. So it's 50, diameter is 50 inches, which means it's 25 from the center to the edge. If the focal distance to the satellite's distance to the satellite, if the focal distance, the distance to the satellite's receiver is 8 inches, find the depth of the dish. So we don't know what this point is. We know it's 0, comma something. In this case, because it's the vertex, it's 0, comma k. We don't know how high it is. We do know the p-value is 8. So we're going to use what we do know to find out what we don't know. Okay, we also know this point right here is 25, comma 0. All right, so we can start making our equation and putting the information that we don't know in to find out what the height of the, what the depth of the dish is, which is the k value of our equation. So I'm going to write the equation. I'm going to put in the stuff in a second. So I'm going to have x squared, because the h value is 0, equals negative 4 times 8, because the 8 is the p-value that we got, and then times y minus k. Okay, because we want to know the depth, so the height of the dish. All right, so now we can put in our point here, 25 and 0 for x and y. I'm going to put 25 for the x equals negative 4 times 8 is negative 32. I'm going to start doing some of that math. The y value is 0 minus k. So 25 squared gives me 625 equals negative 36 times negative k is positive 36k, or sorry, 32, negative 32 times negative k is positive 32k. Divide both sides by 32. And my k value is equal to 19.53. That's it. All right. We're keeping going. The overpass in shape of an upper half of an ellipse spans a bike path that is 34 feet wide. So if we draw our picture, if the whole thing is 34, then we're going to divide it in half, which gives me 17 from the center to the outside edge. The highest part of the overpass is 15 feet from the bike path, so that's 15 here. So now we know 2 points. We actually know 3. The center of our ellipse is 0, comma 0. The b value is 15, and this point is going to be 0, comma 15. And then this point is 17, comma 0. Actually, we don't really care about some of these points. We care about the values next to them, but that's okay. All right. So before we move on to find out the rest of this question, we're going to make the equation of our ellipse. So since the center is 0, 0, I'm going to have x squared plus y squared equals 1. Because the graph is, the bridges are orientated horizontally, my 17 is going to go under the x. I'm going to square it, which is 289. My b value is going to be 15, so it's going to be 225. And that's my equation of my ellipse. Now, part of the question says, how high is the overpass 7 feet from the edge of the bike path? There we go. So kind of like before, this tells you, I'm going to go back to blue. This tells you that this is 7. We want to know how far this is, or how high that is, that point is. The problem is we don't need the 7. We care more about this distance here, which is going to be 10. So this point is really 10 comma y, not 7 comma y. It's 7 feet from the edge, but again, we only care about how far it is from the center. Okay. So we put 10 in for the x value over 289 plus y squared over 225 equals 1. We're going to subtract 10 squared over 289 from both sides. So 1 minus 10 squared divided by 289 gives me a really ugly number, so I'm going to turn that into a fraction. So I'm going to have y squared over 225 equals, I'm going to make it into a fraction because I don't want to do the decimal. I want to be as accurate as possible. All right, so it's 189 over 289. That is a 9, not a 7. There we go. Okay. So I'm going to multiply both sides by 225 to continue getting my y squared term by itself. Okay, so y squared is equal to, I'm just going to leave it as a fraction. So I'm going to keep the fraction in there. It'll become not a fraction in a moment. 42525 over 289. Then I got to square root both sides. And y will equal 12.13. If you had a decimal for the last part before we square rooted it, that's fine. I'm trying to keep it as accurate as possible. So if I rounded it once when I did 1 minus 10 squared over 289 and then rounded it again when I multiplied by 225, I'm becoming less accurate. So I'm trying to keep as the problem as accurate as possible. Okay? Because if you keep rounding it, you're not going to get 12.13, you're going to get something else. It will be somewhat close, but it's going to be not close enough, let's say. Okay. All right. We've never got the next one is going to be based on a hyperbola. Jeff is stationed 10 miles due west of Carl in an otherwise empty forest in an attempt to locate an elusive Sasquatch. At the stroke of midnight, Jeff records a Sasquatch call 9 seconds earlier than Carl. The speed of sound that night is 760 miles per hour. The equation that you're giving represents the hyperbolic path along which Sasquatch must be located. How far north is Sasquatch if he is 3 miles west of Carl? All right. So we want to know if we want to know the y value if the x term is 3 away from Carl. So 1, 2, 3. So our x term is 2, and we want to know what the y value is going to be. Okay, so what we're going to do, all right, let's go back and make sure that you understand why I put down 2. If the Sasquatch is 3 miles west of Carl, we go to Carl on our graph here, we count 3 miles west. So it's 1, 2, third mile. But that third mile is 2 from the center. So it's kind of like when we're doing the ellipses. We're trying to figure out the distance from the center, not from a point on the graph. So the x value of our piece that we're trying to find is 2. So we're going to put 2 in for the x term. We're trying to find the y term. So if we put 2 in for the x and we're given the equation, over 0.9025 minus y squared over 24.0975 equals 1. Now we're going to solve for solve for y, kind of like what we've been doing with the ellipses. Okay, so we're going to subtract 2 squared divided by 0.9025 from both sides. So 1 minus 2 squared divided by 0.9025. There we go. It's going to equal some big piece. So I'm going to make that a fraction to make my life a little bit easier in terms of keeping it all in the calculator, because I don't want to round it multiple times. So I have negative y squared over 24.0975 equals negative 1239 divided by 361. All right. Now, if you have a decimal, you want to convert it into a fraction, you just hit math, enter, enter. And even if it's a calculator 84, that's what it does. So if you're doing calculator 84 on your iPad, that's what you can get. Okay. Now we're going to multiply by 24.0975 on both sides. So times 24.0975. I'm going to give myself a fraction again. Oh, it doesn't like that fraction. So I don't have a choice. I have negative y squared. Actually, you know what I'm going to do? I'm going to make this a negative so I can get rid of this negative. All right, and then I don't have a negative in my problem here. That's okay mathematically. I didn't break any rules, and I don't have to divide everything by -1 before I square root it. So I make my life a little bit easier. So I have 82.71. Okay, I'm just going to round it. I'm not going to round it on my calculator because I don't need to. It stores the information in memory. But then I'm going to square root that answer to get y is equal to 9.09 for my y value. That's the answer. So it's 9 miles north of Carl. All right. Last one. This is it. Long-range navigation is called LORAN, is a radio navigation system developed during World War II. This system enables a pilot to guide aircraft by maintaining a constant difference between the aircraft's distances from two fixed points. It's called the master station and the slave station. The equation, you're given it, represents the hyperbola depicted in the picture below. Solve for x when y is equal to 90. So basically, it's kind of what we're doing up top. We're solving for x when the y is 70. So in this case, I'm going to add 13 times 70 squared divided by 129,600. I'll get it. Okay, so these will go away. I'll have x squared is equal, or x squared over 14,400 equals 1 plus, let's do this whole big thing, 13 times 70 squared divided by 129,600. Gives me a small little number. Can I make this into a fraction? I can. Which gives me 1933 over 1296. Again, the only reason I'm using a fraction is because when I write it down, I don't want to round the decimal because it becomes less accurate. All right, from here, I'm going to multiply both sides by 14,400. So I'll have x squared equals times 14,400. It gives me a decimal. Let's change that. Yeah, I'm going to leave I'm sorry. It gave me a fraction. I'm going to leave it as a fraction just for the sake of that it's still there. Divided by 9. And I'm going to square root both sides of that. And I get x is equal to 146.55. And that's it. I'm done. All right. Hopefully you've tried this out. You have some success. Make sure if you have questions on Thursday before we take the test on Friday that you ask them so we can get them answered. I can help you out.